So one of the other transformations that you need to understand are using vectors to translate something. So translation basically means that you keep the same object, but you're going to move it along the grid using either horizontal or vertical or both directions. So, for instance, when you usually see a point, you usually see something like this. So, say for instance, I had -1, -2. That means that I have my x value and then I have my y value. So I would travel along my x value to -1 and then I would travel down my y value to -2 and my point would be here. Now that just means it's a stationary point, it just sits there. Now sometimes you see coordinates, or they look like coordinates, written sat on top of each other, usually with a big bracket around them, but unfortunately I'm not quite sure how to write that in GeoGebra at this present time. Now when you see them stacked on top of each other, that means it's not a stationary point, it's a movement. And the movement maps on to the same directions as the coordinate axes in front of you. So this is your axis, these are your axes, and here notice that when you're describing the x value, positive numbers are on the right hand side and negative numbers are on the left hand side. And notice when you describe y, that positive numbers are up on the vertical and negative numbers are down on the vertical. So when you see them stacked, it means there's a movement. And as with all other coordinates, or anything to do with the Cartesian grid, which is what this is here, 5, the first number you come across would describe your x movement, and your second number would describe your y movement. So for instance, if I take this triangle, I'm just going to move it to a slightly nicer place first. Okay, and I'm going to translate it by a vector of 5, 2. That means that each point on this shape has to be transferred by 5 in the positive x direction and 2 in the positive y direction. So really, the vector that I'm seeing is each point is going to be moved this distance. It's going to be moved 5 this way, 1, 2, 3, 4, 5, and then it's going to be moved up 1, 2. So basically, all of my points are going to be shifted. So this point is going to be shifted to here, and this point is going to be shifted to here, and this point, woo, that was silly, and this point is going to be shifted to here. So what I'm going to do now is mark them. So this point is going to be 1, 2, 3, 4, 5 that way, up 2, and it's going to sit here. Let's check whether it's marked it or whether I need to move this out of the way first. Okay, and then here, 1, 2, 3, 4, 5, and up 2, so it's going to be here. And I can check it with my computer. Yay, it works. And here, the last one, 1, 2, 3, 4, 5, and up 2, it's going to sit there. So let's check it. Perfect. So now I can join up all of the points that I've made and moved it by accident to click happy. And I should end up, if I've done it correctly, with an identical shape. So translations don't actually change the shape or the size. Translation is just a movement. You're taking a congruent shape, so congruent means identical. So congruent is spelt like this, so you get used to seeing it. Congruent, okay, and that means identical. So translation doesn't change anything about the shape, just where it sits. These two shapes are described as congruent. They are identical in every way. Job done. So let's try doing a negative translation. So let's change these. Oops, wrong click. There we go. Hey. So let's do -2, and this could be 6. Okay. So let's start with our original shape. Let's get rid of the stuff we don't need. So now my translation vector is going to be going across 2. So first I'm just going to put my point on a grid so I can help myself, okay? And I'm going to go across 2, and then I'm going to go up 6. So 1, 2, 3, 4, 5, 6. So you won't obviously have this in your exam, but I'm just using it so I can show you, so I can check my work. So you're going to have to count it by hand. So let's move this point first. So 1, 2, and then up 6. 1, 2, 3, 4, 5, 6. And then this one, 1, 2, 1, 2, 3, 4, 5, 6. And just check, look. This one is down 2 and across this way 2 to get to the next point, so it should stay the same. Down 2, across 2, yep, they're in the same relationship. The distance between here and here is identical, so they're congruent so far. And then this one is back 2 and up 6. 1, 2, 3, 4, 5, 6. Done. So now let's join them all together. 1, 2, so let's check it. So this has been moved back 2 and up 5, so now we can just check, yep, that all of the points sit in the right place, which they do. Perfect, job done. And that's all translation is. Just remember that like coordinates, your x is described first and your y is described second, and if your numbers are stacked on top of each other, then that's a movement, not a point. Job done.